Today we're going to talk about similar figures. Here's some vocabulary to review. The symbol given here is used to represent something that's similar. For example, we know the equal sign has the two bars to represent that something is equal. A is equal to A, 5 is equal to 5. Well, here in this case, when it has a little bit of a swirl, it means similar. So that means that the shape has the same shape, but not the same size. So for example, you maybe have a small square labeled A, B, C, D, and then a large square labeled E, F, G, H. So they are the same shape, they're both squares, but they're different sizes. The symbol given here is just to state that it's a triangle ABC. So a triangle ABC. So if you're given a triangle and it is labeled A, B, C. And the next symbol, you have line segment DE. So this line that's above the DE represents line segment, which is a line or side that connects DE. So I have a triangle labeled as DEF. Okay, so this side here is your line segment DE, and you would represent that with a line over the letters D and E. And the next symbol, it says angle HIJ. So this symbol that almost looks like a less than symbol means that you have angles connecting points H, I, and J. So here if I draw an example, draw an arrow to make sure it keeps going. It's not going to stop. So if I label this H, I, and J, so this is considered angle H, I, and J. The middle letter, the middle point, needs to be your middle letter when labeling. So your vertex needs to be in the center. The last symbol is an equal sign with a similar symbol above it. This represents congruent. For something to be congruent, it is the same size and shape. So all the measurements and everything are all the same. So things to remember when figures are similar. Only the angles are congruent. So in the example below, if these two are similar, that means angle B is the same size as angle H. and the side lengths are corresponding, meaning you see how the shape is in the same position? So that means line segment AB is going to be corresponding or in the same location on this other shape. So it corresponds with HG. So let's look at a few examples. So ABCD is similar to GHEF. Let's see if that's true. A, B, C, D. Okay, and this one's got to go in the same order. G, H, E, F. So you notice how it started in this bottom left corner and it worked its way clockwise around the figure. This one did the same thing. So then these two are written, this is written correctly. F, E, H, G. So F, E, H, G. So you start in the bottom right hand corner and go counterclockwise. Is similar to A, B, C, D. A, B, C, D. Notice how they did not start in the same location. So this example is incorrect. Angle A is congruent to angle G. See how angle A corresponds to the same location of where angle G is? So that means that this statement is true. B, C, D, A. So start with B, C, D, A. So it starts in the top left corner and it works its way clockwise. Is similar to H, E, F, G. Does the same pattern. So those two are similar figures. Line segment AB corresponds to GH equals CD, which should correspond to EF. Okay, so that is a true statement, a true proportion. And the last one, BA, so BA corresponds to HG, and it goes same order, top to bottom. BA, HG corresponds to, or is equal to, FE and DC. So you notice that they started with FE, and then when they went to the other shape, they went from bottom to up as well. Okay, so it's all about order when dealing with similar figures. Let's go ahead and look at the next page. Steps to determine if two figures are similar. First, take the first set of corresponding sides and write them as the first fraction of the proportion. Second, take the other set of corresponding sides and write them as the second fraction of the proportion. Cross multiply. If it forms a true proportion, or in other words, the fractions are equivalent, then the figures are similar. Okay, so in this first example given, you have triangle A, B, and C, which is the large triangle. So you notice A, B, and C. Is similar to triangle ADE. So if this is the case, when we set up a proportion, you can say AB corresponds to AD. So you notice on your symbols, AB is the first two letters over here, and then over here AD is your first two letters in the second symbol. So in your next fraction, it wants to know what corresponds to AE. So you can either look at the picture or the letters. The picture, AE, is right here. So this should correspond to that same side of AC. You can also look at the letters. A is first, E is last. So over here on this symbol, A is first, C is last. So you can use either a picture or the symbols to figure out your proportion. In problem 2, you can set up a proportion to find a missing side. So for instance, remember proportions, order matters. I can say x over 4, because those are the corresponding sides, equals 22.5 over 15. Remember, whatever figure you start on, okay, you got to start on that for both fractions. So let's see which one of these A, B, C, or D could follow a proportion like this. In the first one, A, it says 4 over 15. So if I went denominator to denominator, 4 over 15 equals, actually let's backtrack for 2 seconds. So you could set up the proportion this way, or you could set it up a second way. You could say as well x over 22.5 and say the large figure equal to 4 over 15, the smaller figure. So now looking at these, if I said an A, 4 over 15 equals 22 over x, that's not right. It's got the second fraction mixed. 4 over x, so this flipped, should equal 15 over 22. This one does not. X over 15, so this has completely different, doesn't even go with corresponding sides. 4 over 15 equals x over 22. So your answer is D. In example 3, it states already in the directions that these two triangles are similar. So to figure out the scale factor, you're going to divide. Take the scale of the larger figure. So in this example 8.1, I'm going to go to that corresponding side, which is 2.7, and I'm going to divide them. So when I divide these, I get 3. You should be able to go from any of these corresponding sides. Make sure you read your directions though, because this one says triangle A to triangle B. So that means you're going to start with this triangle A. So I could say 10.2 divided by 3.4. That's going to be a big difference. If you go backwards and start with triangle B to triangle A, then that's going to flip your answer. In problem 4, there's a pair of similar triangles, so it tells you they're similar. Which of the following proportion is true for these triangles? I want you to pause the video and try number 4. You should have gotten A. One thing you'll need to recognize is the fact that this triangle has been flipped. So sometimes it helps to redraw it if you're able. So now you can clearly see that the proportion is going to be A. Turn to the next page. Steps to find a missing measurement. Determine the corresponding sides, set up your proportion, cross multiply and solve. Make sure you label your answer and check your work. Step 1, or problem 1, which must be the value of x in order for the figures to be similar? Since I know my x has to be involved in the proportion, you want to make sure that is one of your fractions. So in this case, x over 8. And I'm going to use two corresponding sides that I already have both measurements on. Since I started in figure 2, I'm going to continue to start in figure 2. So it should be 15 over 10. So I have my proportion. I can set it up as an equation. And I can solve. You need to be able to show your work on this. Proportion equation solution. That should sound familiar. Pause the video and try 2, 3, and 4. Check your answers with the following problems. If you have any questions, ask your teacher.